The Space Telescope brought to light a hitherto unknown universe. It revealed celestial regions hidden under dense layers of dust, offering improved images of cosmic wonders that the Hubble Space Telescope had already captured. These revelations have challenged our assumptions about the behavior of the early universe. And now, using the Webb telescope, astronomers have conducted a recent study that has left them baffled. After 50 hours of observation in the depths of the cosmos, they discovered something they still can't explain. Welcome to Cz Sciencee. Together we will unravel this discovery. Well, we all already know how the Webb telescope detected star formation in the dark age of the universe. Now, by looking intensely at the cosmos through this telescope, astronomers have spotted some of the earliest galaxies ever formed, over 13 billion years old. Considering the estimated age of the universe is 13.8 billion years old, it is a remarkable achievement to be able to capture such a comprehensive cosmic view, displaying objects previously undetectable by humankind. This was only possible thanks to Webb's advanced infrared detection capabilities. However, what makes this discovery even more intriguing is that these primordial galaxies emitted an astonishingly high amount of energy into space, 10 times greater than what scientists predicted. This finding raises a crucial question: how did these forming galaxies achieve such energy output? Scientists now refer to this as the key question. Advanced computer simulations have attempted to model the evolution of the universe over billions of years, including the formation of stars, galaxies, and the organic building blocks of life. However, none of these simulations predicted the extreme levels of ultraviolet energy observed. There are possible explanations for this phenomenon, such as the presence of highly energetic young stars that emit an abundant amount of energy, surpassing the output of our own medium-sized sun. Alternatively, this ancient radiation could have been generated by supermassive black holes, which are hundreds of thousands to billions of times more massive than the Sun and usually found in the centers of galaxies such as our Milky Way. So what's the answer? Singular black holes or active giant stars? To answer that question, let's take a closer look at what astronomers have discovered by peering deep into the cosmos. Well, initially 44 galaxies were identified that probably formed in the first 500 million years of the universe. These galaxies emitted ultraviolet light, which was later stretched to infrared wavelengths. However, this discovery has generated more questions than answers, while also arousing enthusiasm among researchers. Most scientists are now inclined to believe that supermassive black holes are responsible for the early light in the early universe. However, this raises the big question of how these black holes formed. Most black holes form from the remnants of massive stars that die in supernova explosions. Therefore, the existence of stars is crucial for the formation of black holes. Without stars, there would be no black holes unless they formed directly from stellar gas, known as direct collapsing black holes. This suggests that there may be even older stars than those found so far with the help of the James Webb Space Telescope. It seems that our universe is stranger than we imagined. Indeed, in the foggy beginnings of the universe, a surprising object caught astronomers' attention. Observations made by the James Webb Space Telescope have revealed the presence of an active supermassive black hole, about 10 million times more massive than the Sun, which is continually growing while consuming matter around it. This is the oldest growing supermassive black hole ever detected, occurring just 570 million years after the Big Bang. Although scientists hope that this record will not last long. The black hole was found inside one of the first galaxies ever observed, formerly known as Cz 8p7 and now called Source 1019. This discovery could contribute to understanding one of the biggest enigmas of the early universe, how black holes in the cosmic aurora grew so quickly to reach such large sizes. The most distant active galactic nucleus and oldest black hole ever identified has been found, according to an astrophysicist involved in the discovery. Initially, scientists were studying the 1019 source to investigate the light produced by star formation in the young universe. This light, called Lyman alpha emission, is believed to result from the ionization of neutral hydrogen by star-forming activity. In the beginning, the universe was filled with a haze of neutral hydrogen, which blocked the propagation of light. Only after the ionization of this hydrogen could light spread freely. This period of reionization, as it is known, is still not completely understood. We know that it occurred in the first billion years after the Big Bang, 13.8 billion years ago. However, it is extremely challenging to observe this far into the early stages of the universe. Source 1019 and some other ancient galaxies are ideal targets for this survey because they are relatively bright. The galaxy was identified in Hubble Space Telescope data in 2015, and at the time, it was the most distant galaxy ever observed. Later observations confirmed its existence, but obtaining more detailed information has been difficult, as the oldest light in the universe has shifted into the infrared spectrum due to the expansion of the universe. It takes a powerful infrared instrument, like the James Webb Space Telescope, to investigate them. When the James Webb Space Telescope became available, Cz 1019, the brightest galaxy identified by Hubble in that period, became an obvious target. The telescope observed the galaxy for just an hour, using all 4 of its instruments, and returned with a wealth of data. At that point, I was blown away by everything we got to see with James Webb. We've observed this part of the spectrum from this galaxy and other galaxies in the early universe that we've never seen before, said astrophysicist Rebecca Larson. I was impressed with the amount of information obtained. However, she noticed something unexpected. In addition to the light coming from star formation, there was a broad emission feature usually associated with active galactic nuclei. When she shared this observation with other active galactic nuclei researchers, things got even more interesting. Normally, a galaxy in the early universe emits light from an active galactic nucleus or from star formation. Seeing both in the same galaxy was extremely surprising. The black hole is affecting the emission lines we observe, but most of the light in our images is still dominated by the region of the galaxy where star formation takes place. It's not all that surprising to discover that a supermassive black hole has existed for over 13.2 billion years and is growing. Much larger black holes have already been detected in the early universe. However, scientists still don't know how the black holes in these galaxies managed to reach such massive sizes in such a short time. Recently, galaxies were found that formed just 300 million years after the Big Bang. These galaxies are large and complex, and scientists around the world were perplexed that, according to the standard model of cosmology, these galaxies should not have existed so soon. These galaxies were initially observed as fuzzy spots that appeared exceptionally bright and reddish. The team of astronomers who discovered them called them universe crackers because, if they are real, their existence calls into question our entire understanding of galaxy formation. Explaining the presence of these massive galaxies so close to the beginning of time would require a review of the basic rules of cosmology and our understanding of how the first galaxies formed from small clouds of stars and dust. The discovery of these massive galaxies so soon after the Big Bang suggests that the Dark Ages may not have been as dark as previously thought, and that star formation may have occurred much earlier in the universe than we thought. Now, with the discovery of this black hole just 500 million years after the birth of the universe, we have a mystery on our hands. The picture of the early universe is changing faster than we expected, and it's time to revise our theories. The James Webb Space Telescope continues to push the boundaries of knowledge, providing valuable insights into the mysteries of the universe. As we look forward to new discoveries that will bring answers and new questions, the Webb Telescope continues to lead the way in scientific